Inverse variation occurs when the product of x and y is equal to a constant value. Just like when we talked about direct variation, in this variation, inverse, k is the constant of variation. There are two ways to look at an equation for inverse variation. The most direct form is x times y equals k. Another form is y equals k divided by x. Y equals k over x comes from the same equation as xy equals k. For example, if we simply divide by x on both sides here, that gives us this equation. When you're looking at a table, in order to tell if it's a direct variation relationship, we simply need to know that x times y is equal to a constant value. If we look at this first table, x times y, we want to know if it's a constant number for each value of x and y. 1 times 12 is equal to 12. 2 times 6 is equal to 12. 3 times 4 is equal to 12. And 4 times 3 is equal to 12. Since all of our values of x and y produce a product of 12, this is inverse variation. Let's look at the next example. 1 times 5 is 5. 2 times 10 is 20. 3 times 15 is 45. And 4 times 20 is 80. Since x times y is not equal to a constant value, this is not inverse variation. To determine if an equation is an inverse variation, we simply need to know if that equation can be written in the form y equals k over x, or if it can be written in the form x times y equals k. Let's look at these examples together. Y equals 6x. In this equation, this is actually representative of a direct variation because it's in the form y equals k times x. In order to have inverse variation, we need to have y equals k divided by x. If we look at the example below, we can see that this equation is written as y equals k divided by x, where k is 8. So this one is inverse variation. The next example is x times y equals 18. Since this is written in the form x times y equals k, where k is 18, this is inverse variation. And for our last example, y equals negative 3x is in the form y equals kx, which represents direct variation. So this is not an inverse variation. Now let's look at some word problems. To write an inverse variation equation, that simply means that we need to write that x times y equals k. So if x times y equals k, we can find k by simply looking at x and y that's given to us originally. If y is 10 when x is 5, that means if x is 5, y is 10, what does that equal to? Well, 5 times 10 is 50. So every x times y has to equal 50. So to find y when x is 2, we can simply plug in x as 2 for our inverse variation equation. So if x is 2 and we want to know y, but we know that x times y has to equal 50, we simply plug in those values and solve for y. So we can divide by 2 on both sides. And our final solution is that y equals 25. Let's do another one. If y is negative 16 when x is 4, find x when y is 32. First, we need to set up our inverse variation equation, which is x times y equals k. So if x is 4 and y is negative 16, we can find what that product is. So negative 16 times 4 is negative 64. So negative 64 is always going to be the product of x and y. So there's another way you could think about this. If x times y always needs to be 64, then you could simply take the second piece of information and find x when y is 32 by simply thinking about what number times 32 would give me negative 64. So, what number times 32 is equal to negative 64? You can divide by 32 on both sides, and you would get negative 2. Now let's look at graphing inverse variations. Beginning with the example on the left, we're going to look at the equation y equals 4 divided by x. Or if we wanted to rewrite this so that it looks like xy equals k, we would simply multiply times x on both sides, giving us xy equals 4. Using this information, we can fill out a table. So if x times y is always equal to 4, then we can simply think about what are some x values, what would we have to be multiplying by in order to get 4. So if we start with some negative numbers, I'm going to start with negative 4. So if x is negative 4, and the product of x and y has to be positive 4, then negative 4 times negative 1 is what is equal to positive 4. Okay, if I think about the x value negative 2, if x is negative 2, then what number should I multiply by so that the product is positive 4? It would have to be negative 2. If our x value is negative 1 times negative 4 is equal to positive 4. I could also pick some positive x values. So if I pick the positive x value of 1, what would the y value be so that the product x times y is equal to 4? That would have to be positive 4. If I picked positive 2, then positive 2 times 2 is equal to 4. If I picked positive 4, then positive 4 times 1 is equal to 4. So notice, all we had to do to find a table was to make sure that x times y was equal to 4. Now we can plot these values in the graph. So if we start with the x value -4, we would go over to -4 and down to -1, -2, -2, and -1, -4. Then we can plot the points 1, 4, 2, 2, and 4, 1. Notice that this doesn't look like a straight line. It's certainly not a direct variation. When we connect this line, it's going to look kind of like the laces on a baseball or the laces on a softball. This is the graph of an inverse variation function. Let's do another example with a word problem built into it. The area of a rectangle is 18 units. Let's stop right there and talk about the area of a rectangle. The area of any rectangle or square is always the length times the width. Okay, so if the area is 18 square units, then 18 is always going to be equal to the length times the width. The relationship between the length and width varies inversely. That's important. So now we know that we're going to set up our inverse variation equation. So if x is the length and y is the width, then our inverse variation equation would look like x times y equals 18, because the length times the width is equal to the area. Now we can pick some x and y values to go in this table. Starting with 1, if x is 1, what would y have to be so that the product is 18? That would have to be 18. If x is 2, y would have to be 9. To pick more x values, all we have to do is simply think about what times what gives me 18. So the next value I could choose would be 3, since 3 times 6 is 18. 4 times a number is not going to give me 18. 5 times a number is not going to give me 18. 6 times a number does give me 18. 7 times a number won't be 18. 8 times a number won't be 18. 9 times 2 gives us 18. 10, 11, 12, 13, 14, 15, 16, and 17 do not go into 18 evenly, so the next number would be 18 times 1. And we can't go any further than that. I realize our graph isn't big enough to hold x and y values of 18, but it is big enough to hold x and y values up to 9 or 10. So we're going to graph what we can. We can't graph 118 because our graph isn't large enough, but we can graph 2, 9. We can graph the point 3, 6. We can graph 6, 3. And we can graph 9, 2. Then we just want to connect this with a smooth curve. Now, just to reiterate what is happening here, we were told that the area of a rectangle was 18. And we were told that the relationship between the length and width varies inversely. So that means that the length times the width had to equal 18. So our length was x, width was y, and the area was 18.